Hi guys, today's lesson is lesson 98. It is called Relations and Functions. So a relation is a pairing of two sets of numbers. If you think of pairs, they have to have two numbers. So this might be something like a name is paired with a phone number, or an athlete is paired with their jersey number. These can be described in set notation with a table, with an equation, or with a graph. All right, some review. These are words we've heard before, but you might not necessarily remember them. So if you hear the word domain, think of that as being an input into our equation. It's usually x. The range has to do with the output, and that is usually y. So if we had an equation, y equals 2x, we could make a table, right? And then we could choose our input values. So if I chose -2 for x, 2 times -2 is -4. So my output would be -4. If I chose 0 for my input, 2 times 0 is 0. So my output would be 0. If I chose +2 for my input, 2 times 2 is +4. So my output would be +4. All right, today's lesson centers on functions. So a function takes one input, which is usually x, and assigns it to one output, which is usually y. So not all relations are functions. We're going to look at the difference between those right now. All right, so this first table on the left here is a function. If we look at our inputs, which are x, we want every input to have its own output. So 0, 0, 1 goes with 7, 2 goes with 14, and 3 goes with 21. None of the x's match, which makes this a function. Okay, so none of the x's match. All right, let's look at this table on the right here and see why this is not a function. Do we have any x's that match? Let's see, I have 4, 10, 12, 10, 6, 4. All right, so my 4's match. Let's start with those. If x is 4, y is 50. That's what this top row is saying. If x is 4, y is also 60. So because these x's match, but the y's do not match, this means that this table does not represent a function. In order for it to be a function, every x needs its own y value, right? We could also look at 10. See how when x is 10, y can be 20 and 25. Since these y's are different numbers, that means that this is not a function. All right, to check if something is a function, we use something called the vertical line test. So think about a vertical line goes up and down. So if a vertical line can be drawn that passes through more than one point on the graph of a relation, then the relation is not a function. So if your line passes through one point, it is a function. That equals a function. If your line passes through more than one point, it is not a function. It's not equal to a function. So let's take a look at some of those examples. All right, which of these are functions? So my first graph right here, I'm going to draw the vertical line test. No matter where I draw my green vertical line, it's only hitting each part of the function one time. It crosses here, 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 right? So this is a function. All right, let's look at this one. Let's draw a vertical line. Uh-oh, I crossed my graph twice. So do you see how I crossed my graph twice? It doesn't matter where this happens. This means that this is not a function. All right, what do you think about graph 3? Function, not a function. Draw your vertical line. No matter where I draw my vertical line, it only hits my function or my graph one time. So this is a function. How about 4 here? Function, not a function. All right, if I draw a line here, it hits it twice, right? If I draw a line here, it hits it 3 times. So graph 4 is not a function. How about graph 5? Function, not a function. Draw your vertical line. No matter where you draw a vertical line, it only hits the graph once, so 5 is a function. How about 6? Function, not a function. All right, let's draw my vertical line. Uh-oh, this graph is a vertical line, so this is definitely not a function. It hits it the whole way down. All right, graph 7, function, not a function. Draw your vertical line. The vertical line only hits these once, so this is a function. All right, how about this funky looking graph? Graph 8, function, not a function. All right, if I start way over here on the right-hand side, looking pretty good so far. It only hits it once, right? But when I get a little farther over, that's where I run into trouble. All right, so this one is not a function. All right, functions can be linear. Think about what the word linear means. Linear means line. So here's a line, that's a function. Horizontal lines can be functions, right? This is a positive slope on number 1. 3 is a negative slope. 4 is another horizontal line. Those are all functions. Functions can also be non-linear, so they don't have to just be a line to be a function, right? As long as they pass this vertical line test, then we know we have a function. So all of these orange graphs are functions. They are just non-linear functions. All right, scatter plot. This is kind of has nothing to do with functions really, but the Saxon book smushed them in the same lesson. So scatter plot, we've already talked about these before, are graphs showing data points on a coordinate plane that represent pairs of related values from 2 sets of data. So we've talked about correlation. These are relationships between data. And to find the correlation on our scatter plot, we can draw a line of best fit. Your book might also call this a trend line. It fits into most of the data. So if we look at these 2 scatter plots here, could we draw a line of best fit? So we want a line that fits through most of the data. So I would not want to draw a line on this orange scatter plot way up here because it doesn't actually go through any of the data. So that would not be a good trend line or a line of best fit. I want a line that goes through, pretend that's a straight line, that goes through the majority of the data. All right, same thing for my green line. I wouldn't want to draw a line across like this because that doesn't go through the majority of my data. So I would rather draw a line that goes through a majority of the data, right? All right, when we look or think about correlation, we want to determine if something has a positive or a negative correlation. So we want to think of slopes, right? I guess I should make positive green. All right, if we're thinking about slopes, right? If something is an uphill line, that's a positive slope. So here is a strong positive correlation. The second graph is a weak positive correlation. It's kind of going up, but it's pretty far apart if you think about going this way or this way, right? This one up here is strong because all the data is really close to this trend line that I drew. All right, and the bottom graph on the left here has no correlation. The data points are just really sporadic. All right, think about slope. Negative slopes have downhill lines. So this top graph is a strong negative correlation because they're all really close together. We also can have a moderate correlation. So this middle one would be a moderately negative correlation. You can have a moderate positive correlation as well. And then here's a weak negative correlation. It's still mostly going downhill, but they're all really spread out. All right, if you would like more practice with figuring out functions versus not functions, please check out the practice set on page 654 in your textbook. And let me know if you have any questions. Thanks.